Hey everyone, Chang here and welcome to my channel. Today we're going to put a humongous effort on going over lazy form of mathematics. I mean, come on, who wants to put more effort than necessary? That's right, today we're going to be going over exponents, basic properties of exponent. By the end of this video, you're going to know what exponents are, what are some properties that you have to quote-unquote memorize, which is actually not all that efficient, and some common mistakes that you will encounter when working with exponents. So let's begin. Exponents are nothing more than repeated multiplication. So instead of writing the multiplication out all the way, we decide to use exponent to represent that instead because it's more efficient. Well, you know, lazy. Here are some examples of exponents. The first one here we have is 2 to the 4th power. It basically is saying that 2 times itself 4 times. 2 times 2 times 2 times 2. Another example, here is 7 to the 3rd power. Basically 7 multiplied by itself 3 times. I want you to notice that in this notation of exponent, this format of exponent, we have this large number and then a small number on top. Well, the large number is known as the base. That is the number that's being multiplied however many times you want. The small number is where the names come from, exponent. That's the actual exponent. That tells you how many times you want to multiply the base. Now, regarding exponents, there are several properties that you should know about. Some people opt to memorize them. I don't think that's the most efficient way of going about it. When you actually break it down, when you actually look at what each and every one of these properties mean, it actually is quite simple or more common sense than we realize. So I'm going to start off by talking about the first property. In this discussion, I'm going to start using variables so that all of us get comfortable in seeing variables in explanation. So let's look at this expression. Here it's saying 2 to the a power times 2 to the b power equals 2 to the a plus b. Well, a and b here are basically variables. It could represent any number we would like. Now, it actually doesn't have to be base 2 at all. I'm just using 2 as an example here. You can easily use 3, 5, -7, or 1 million. The number is replaceable. The reason I'm choosing 2 instead of putting another variable is because I don't want it to be all confusing with all the different variables. So we'll just use 2. But remember that you can substitute 2 with any number and the properties will still work. Well, what this property is basically saying is that if you have, for example, 2 to the 3rd power times 2 to the 8th power, you actually get 2 to the 11th power. Here we can see that 3 plus 8 is equal to 11. That's why the answer is 2 to the 11th. Or if we use a different number, for example, 6 to the 2nd power times 6 to the 8th power, well, we will have the answer to become 6 to the 10th power. 2 plus 8 equals 10. Simple as that. Now when we break it down, it actually ends up being quite simple. Let's use the 2 to the 3rd power times 2 to the 8th power. Well, we'll look at different components. 2 to the 3rd power is basically 2 times 2 times 2, or 2 times itself 3 times. We have now 2 to the 8th power, which is basically 2 times 2 times 2 times, you know, it goes on. Basically 2 times itself 8 times. Keep in mind that these two are multiplying each other as well. 2 to the 3rd times 2 to the 8th. So if we have 2 to the 3rd, which is 2 times itself 3 times, times 2 to the 8th, which is 2 times itself 8 times, the total amount of times that 2 multiplies itself is basically 3 plus 8, which is 11. And this reasoning can work with any exponents. The second property is actually very similar to the first property. The only difference in this case is that instead of adding the 2 exponents together, we're going to subtract the 2 exponents. The reason is because instead of multiplying 2 exponential expressions, we're going to divide them. Well, let's look at this overall general expression. Here we have 2 to the a power, that means 2 times itself a times, divided by 2 to the b power, which is basically 2 times itself b times. The answer is actually going to be 2 to the a minus b. Well, some example of such is this. 2 to the 24th power, that means 2 times itself 24 times, divided by 2 to the 14th power, which is 2 times itself 14 times. The answer, based on this property, is going to be 2 to the 10th power. Or, once again, if we decide to use a different base, a different number for base, we have 4 to the 8th power divided by 4 to the 7th power. In this case, by this property, 8 minus 7, the answer is going to be 4 to the 1st power, or just 4. Now, the reasoning is actually very similar to the first property as well. If we use the second example, 4 to the 8th power divided by 4 to the 7th, we know that 4 to the 8th power is actually equal to 4 times itself 8 times. 4 to the 7th is 4 times itself 7 times. Now, we also know that when we have 4 to the 8th power divided by 4 to the 7th, it's basically 4 to the 8th over, in the fraction, 4 to the 7th. We can break it all out into this expression where we have 4 times itself 8 times on top and 4 times itself 7 times at the bottom. Now, hopefully at this point you guys are a little familiar with division and you guys realize that we can actually cancel out a lot of these 4 on the top and bottom. Now, here's the thing though, just to make sure that there's no misunderstanding, when we say cancel, it's not really canceling. The top 4 divided by the bottom 4 just becomes 1. So instead of the top being 4 and the bottom being 4, it's actually just 1 and 1. So all these 4s that have matching top and bottom in this fraction will cancel out and become 1s. So on the top, technically, you have 1 times itself 7 times the remaining 4, and the bottom is 1 times itself 7 times. So it's all just 1. So now you have the remaining 4 on top divided by 1, which equals 4. Or in this case, yes, 4 to the 1st power. So the third property is actually very different from the first and second. In this case, we're going to be taking one exponent expression and taking another exponent. So we're multiplying that exponential expression by itself a number of times. This is what the property actually looks like. Now here we have 2 to the a power, which is basically 2 times itself a number of times. That part is simple. But notice that it's actually in the parentheses raised to the b power. So basically this expression 2 to the a is going to multiply by itself b number of times. And what this property is saying is that the end result, the final answer in this case, is actually 2 to the a times b. The two exponents are actually multiplied together. So, for example, if we have 2 to the 3rd power, the whole thing raised to the 4th power, by using this property, we're saying that the end result is going to be 2 to the 12th power, because 3 times 4 is 12. Or if we change the base, which we can, 3 to the 2nd power, the whole thing raised to 4th power, is actually equal 3 to the 8th power, because 2 times 4 is basically 8. So let's use 3 to the 2nd power, all raised to the 4th power, as a way to reason out this property. Well, we know that if we're looking from outside in, 3 to the 2nd power raised to the 4th power is basically 3 to the 2nd power times itself 4 times. So it's going to be 3 to the 2nd power times 3 to the 2nd power times 3 to the 2nd power times 3 to the 2nd power. Well, we also know that each of these 3 to the 2nd power is actually just 3 times 3. Because, 3 to the 2nd power is just 3 times itself twice. Well, in that case, each of those 3 to the 2nd power becomes 3 times 3, giving us a total of 3 times itself, well, you guessed it, 8 times. And this reasoning works with any base and any number. Now, there's actually a few more properties, but I feel like those would be considered more of the advanced exponents, and I will try to cover them in a future video. Well, let's go over 2 common mistakes that normally occurs when working with exponents. The first one involves the base. Notice that for each and every one of the properties, well, more specifically the first 2 properties, the bases have to be the same before you can either add the exponents together or subtract the exponents. If the base are different, then it just makes no sense. Here, let's look at this example. So if we are working with 2 to the 4th power and 3 to the 7th power, for example, notice that their base are drastically different. The first base is 2. While the second expression, the base is 3. If we were to try to add them, let's say 2 to the 4th times 3 to the 7th, well, adding the exponents makes no sense because we know for a fact 2 to the 4th power times 3 to the 7th, it's not going to be, well, a possible combination 2 to the 11th, which makes no sense, or 3 to the 11th. That makes no sense, right? One number is going to be smaller than the actual answer. the other number is actually going to be bigger than the actual answer. Subtracting them will not make any sense either. It will go under the same idea. If you were to have one divide the other, you could either have 2 to the 4th divided by 3 to the 7th, or 3 to the 7th divided by 2 to the 4th. Realize that the answer is going to be drastically different. The second common mistake actually has to do with something along the lines of distributive property. Well, here's an example. Here we have 3 plus 4 parentheses squared. Well, in this case, it's going to be equal to 3 squared plus 4 squared, right? I mean, distributive property, distribute the exponent. That's not necessarily the case, and we can actually verify this. In the parentheses, if we have 3 plus 4 squared, basically 3 plus 4, if we add them together, is 7. 7 squared. Well, 7 squared is 49. On the other side, however, we have 3 squared plus 4 squared. 3 squared is 9. 4 squared is 16. 9 plus 16 is 25. Well, 49 and 25 are clearly two different numbers, so this kind of assumption doesn't work. Now remember, when you see something like this and you can actually combine the inside, do so. If not, properly distribute them all out to see what the answer is. Do not assume that because you see an exponent on the outside of the parentheses that you can just distribute the exponent in. Doesn't work that way. Well, that was easy. Pretty simple, pretty straightforward, not too bad, not too complicated, right? You try.
1.
Just a keynote, I will have the answers in the description for those of you guys who are curious and want to check your answers.
3.
Well, thank you for sticking with me until the end of this video. Let's summarize basically what we went over. We covered basic exponents. Exponents is nothing more than repeated multiplication. Now, in the format, we see there's a large number and a small number. The large number is known as the base, the number that's going to be multiplying by itself however many times you desire. The small number is the actual exponent. That's where the name comes from. That's going to tell you how many times you want to multiply that base. Now there are 3 properties regarding basic exponents. The first property, if you have 2 exponents with the same base and you multiply them together, you just add the exponents. The second property, if you have 2 exponents with the same base and you divide them, then you subtract the exponents. The third one, if you have 1 exponent and you're taking it to the power of another exponent, you just multiply the 2 exponents together. Now there are 2 common mistakes that we would like to avoid. The first one has to do with the base. When we are using these properties, we have to make sure that they are of the same base. 2, 3, 4, or 5 different expressions, if any one of them is not using the same base, you cannot combine them in any way. The second common mistake has to do with a parentheses and exponents on the outside. Usually inside is either addition or subtraction. If you see a problem like this, do not distribute the exponents. If you do, it will result in error. Lastly, please like, comment, and subscribe. Now for this video, I only briefly went over the very basic of exponents. The real fun begins when you start working with the advanced exponents, which hopefully I'll be able to cover in a future video. Lazy math for the win!